Benjamin Caldwell is responsible for any damage done to this basketball goal during the testing of the rim.
What's up? We're here, we're analyzing a basketball goal. We've got our buddy Bobo out here, he's going to do some dunks for us. We're really excited, we're going to try to see if the rim is going to fail. We hope it doesn't because Bobo's our friend and we don't want him to get hurt. But here we go. Alright, so for our project, we decided to take 3 different elements on the basketball goal. We started with the rim. We actually looked at it in 2D because it's circular in 3D. That would provide for pretty difficult analysis, so we decided to just look at it in 2D, and we took these supports and looked at them as 2 force members. It made it as a statically indeterminate problem. And we took basically the force at the end of the rim as the person would be pulling down, in this case Bobo, as he was hanging on the rim. And then after we did the rim, we decided to move to the bolts where the rim attaches to the backboard. In this case, there are 4 bolts, the one that we analyzed. And for the 4 bolts, we looked at how much it would take for it to break, to see where the shear forces, where the bending stress, all that kind of thing would happen. So the last part that we did, we wanted to talk about the horizontal pipe. We took an element between the backboard and the start of the curvature of the pipe. We wanted to look at the forces that would be acting on it, the moment that would be acting on that, the shear forces, that kind of thing. And we wanted to see if the pipe would break up there at the base. For this project, the first thing we assumed was that the force acting on the rim was directly vertical. We decided that it was also a hanging force and not an impulse force. So it was acting, for a constant amount of time instead of at a single instant. When we analyzed each element, we also assumed that the rest of the body was rigid. So like for the base, we took an element at the bottom of the base, and then we assumed that the rest of the body was rigid. We also assumed that the curvature in the pipe was a 90-degree angle, because that curvature would throw in a lot of more difficult analysis. For the materials, we assumed that they were ideal, that there was no weathering involved, as in this case, like you can see some rust on the goal and things like that. We got our specifications from an online source. They were for like the cross-section of the pipe, the cross-section of the rim, the bolts, etc. The other thing that we assumed was that when we assumed the element at the bottom, we assumed that the rest of the goal was rigid. When we took the element in the rim, we assumed that the rest of the goal was rigid. Basically, we just decided to take the body as a rigid body instead of assuming, elastic deformation in that. Also like to thank Benjamin Caldwell for assuming all responsibility associated with any damages that may or may not have occurred during the making of this video.